So part A says, find the first three terms in ascending powers of x of the binomial expansion of 1 over the square root of 4 minus x, giving each coefficient in its simplest form. And this is a 4-mark question. So look at this question. The first thing that stands out to me is that we need to find the first three terms. And quite often in binomial expansion questions, it will tell you how many terms you need to find. So make sure you look out for that in the question. So first thing I want to think about is there anything we can do with this expression to get it into a form that will make it more suitable for carrying out a binomial expansion? So the first thing I want to think about is our indice laws. Now we know that if we do a to the power minus 1, that's equivalent to 1 over a. In a similar way, if we do a to the power of a half, that's equivalent to the square root of a. So sort of combining them together, a to the power of minus a half is equivalent to 1 over the square root of a. Okay, so look at that, that's great, because we can see here, this is actually a really similar form to our expression up here. So I'm going to rewrite our expression up here as 4 minus x to the power minus a half. Okay, fantastic. So this is starting to look like something we can work with. If we look down here, we can see that I've brought in a little snippet from the formula booklet. And this is a formula for binomial expansion. And if we look here, we've got something on the left-hand side, which is in the form 1 plus x to the power of n. Well, look at what we did a second ago. We've rewritten our expression to 4 minus x to the power minus a half. Well, that's great. That's almost in the form that we need here. However, we've got a 4 here instead of a 1. So we need to try and introduce that 1 somehow. So I'm going to write this with a few more brackets to make it clear. Okay, so now we've got this written like this. What we can do is we can factorise out the 4 from this bracket. So we're left with 4 out the bracket here, and then so we're going to have 1 inside the bracket, because 1 times 4 is our 4 here. And we're going to be left here with minus x over 4. And we can see this would work, because if we multiply the 4 back into the bracket, the 4's will cancel, and we'd be left with a minus x. So that's perfect. And we've still got the power of minus a half. Great, so now the last thing we're going to do is using our indice laws, we can take this to the power of minus a half and apply it separately to the brackets and to this multiple of 4. So doing that, we'll get 4 to the power of minus a half multiplied by 1 minus x over 4 to the power of minus a half. Great, now look at this, we can actually rewrite this a bit neater. So 4 to the power minus a half, we can write as 1 over the square root of 4. And actually, the square root of 4 is just 2. So it's just a half. So now using this here, we can carry out a binomial expansion using the formula from the formula booklet. Brilliant, so I'm going to write it out here, and I'm actually going to write it out like this. We've got 1 plus minus x over 4 to the power minus a half. And this just to make it clear, because we can see up here that we've got 1 plus x, and we've got a plus x here. So this means essentially our x term from here, we need to match up with the minus x over 4 here. So I've written it like this with the plus here, so we can clearly see and remember to include the minus here. So we've got half multiplied out. As we can see, the first term is 1 plus n times x, so n is minus a half. And x, and remember we need to include the minus, we've got minus x over 4. And the third and final term that we need to include, so we've got minus a half multiplied by minus a half minus 1, which is minus 3 over 2. And that's over 1 times 2, which is just 2. And that's multiplied by minus x over 4, all squared. And then this will just carry on. However, in the question it says we only need to go up to the first 3 terms, so that's all we need to work out. Now we're going to multiply out these brackets a bit and tidy it up. So again, we've still got the half and the 1 here. Okay, so the minus a half multiplied by minus x over 4. It's going to x on the top over 8. Add it onto here. So I'm going to do this in a couple of steps. So we're going to multiply out the numerator. So we'll get 3 over 4. That's all over 2. And if we rewrite that out, that's the same as saying 3 over 8. That's multiplied by, so if we square this, we get x squared over 16. And in the numerator, we get 3x squared, and 8 times 16 is 128. So we get 3x squared over 128 here. And again, that carries on. So lastly, I'm just going to multiply through the half. So we're going to have a half plus, so that's going to be x over 16 plus 3x squared over 128 times 2, which is 256. Fantastic. And looking back up at the question, it says we need to give each coefficient in its simplest form. And looking down here, we can actually check this, but all these coefficients are already in the simplest form. So this right here is our answer. So the first three terms of the expansion of 1 over the square root of 4 minus x is a half plus x over 16 plus 3x squared over 256. So looking back in the question to see where we get the marks. So we get the first mark here for carrying out the algebraic manipulation and writing 1 over the square root of 4 minus x in this form. We get the second mark for using the correct binomial expansion from the formula booklet. We get the third mark for this line, so for writing out everything in the brackets here. We get the fourth and final mark here for the correct first three terms in the expansion. So now I'm going to have a look at part B. So the expansion that we found in part A can be used to find an approximation to root 2. Possible values of x that could be substituted into this expansion. So they've listed out some possibilities here. And part B says, without evaluating your expansion, in part 1 we need to state giving a reason which of the three values of x should not be used. In part 2 we need to state giving a reason which of the three values would lead to the most accurate approximation of root 2. Right, so we're going to have a look at tackling part B I first. So we need to give a reason and state which of the possibilities that they've listed up here should definitely not be used. And we see here that I've put a little snippet from the formula booklet again. So it's the same snippet that we used in part A. And this is a crucial bit here. The modulus of x needs to be less than 1. Okay, so that's great. So we can work with that. Now from part A, using this formula, we expanded this. Now we see here matching up the parts. The x here is equivalent to the minus x over 4 here. So essentially what we're saying is for this expansion, the conditions are the modulus of minus x over 4 has to be less than 1. Just making it clear, that's because here we've got the x here and the modulus of x has to be 1. So in our expansion here, essentially this is acting as the x value. So the modulus of minus x over 4 has to be less than 1. Right, so if we multiply both sides by 4 of the inequality, we get the modulus of minus x is less than 4. However, because it's a modulus, we can ignore the minus here because the modulus sort of gets rid of that. So the modulus of x has to be less than 4 for this expansion to be valid. Okay, great. So now we've worked out that condition here. We need to look back up at what they said in the question of which of these aren't valid. But if we think about it, if the modulus of x equals 2, well that's just 2, and that is less than 4. Okay, so that's okay. The modulus of x equals minus a half. Okay, so the modulus of minus a half is a half. Half is less than 4, so that's okay. The modulus of x equals minus 14. So the modulus of minus 14 is 14, and 14 is bigger than 4. So no, that's not okay. So writing this out formally, the modulus of minus 14 equals 14, and 14 is bigger than 4, which means x equals minus 14 should not be used, since x equals minus 14 is not valid for the modulus of x is less than 4. Now take a look at B part 2. Now we need to state which value of x will lead to the most accurate approximation of the square root of 2. Now we get the most accurate approximation when we have a value of x which is the closest to 0. See here that we've already ruled out x equals negative 14, because in B part 1 we said that that's not valid. And look at the other two parts, we see, okay, we've got x equals 2 and x equals minus a half. And x equals minus a half is closer to 0 than x equals 2. So x equals minus a half will be the appropriate choice. So writing that out formally, we've got x equals minus a half be our choice because it's closest to 0. So both of these were just 1 mark questions. So we get 1 mark here for correctly choosing x equals minus 14 and giving a valid reason. And we get 1 mark here for correctly choosing x equals minus a half and giving a valid reason.